Hi everybody, I'm going to talk to you about ECS networking today and how you can get more containers on the same size host. So you can get more containers, less money, and some advanced networking bits to achieve that. So first of all, I'm Rick Harvey. I'm based over here in the UK. I'm a staff cloud architect for DoiT, same place that Berger and Czar work. I'm a former AWS technical evangelist and solutions architect. I've got a few links on here, which I'll share the slides after as well, so you can download them, just in case you want to see any of my ramblings on Twitter or look at any of my pull code on GitLab. And then I've got a few containers out on Docker Hub as well. My favorite project, shameless self-plug here, is S3R.io, which is a serverless and databaseless URL shortener built in Lambda and using S3. So check that out if you want. Right, let's get on with the content here. So first of all, I'm going to talk a little bit about ECS and give everyone a 10,000 foot overview of what ECS is and why AWS built it. So ECS is a container orchestration system, a bit like Kubernetes. Everybody's familiar with Kubernetes or Docker machine, for example. What it does is it allows users to basically input a task and a service. A task is a definition of up to 10 containers that are closely linked, and a service tells ECS how many times to run that task within the cluster. The whole ECS management plane is run by AWS. There's no charge for that, that management control plane. It's a $0 value, and it's highly available up all the time. When you come to place a workload with a service, you have something called placement strategies. And the simple one is something called AZ spread, availability zone spread. And this will make sure that if I'm running 4 versions of my task, so in my service, I've defined 4, that will get split up between all the machines across my availability zones. If I had a 3rd availability zone here, it makes sure some machines, some of the instances and tasks get run over in the other availability zone as well. But you can go a little bit further in the thing called placement constraints. Now, what constraints do is basically say when I'm running a particular task, I want to run it only on instances that have got a GPU attached to it. So in my cluster, in the example here, the P3 2XLs, they've got a GPU attached, the C5 larges don't. So in my placement constraints, I would say only run this on type P3, and then that workload will only ever get placed there. Right, that's ECS in a nutshell. The networking side. Let's dive a little bit deeper and have a look at the networking here and try and explain some of the different networking modes you can get with ECS. So in this diagram here, the orange box represents the instance running in AWS on EC2, and here it has a network interface attached. Elastic Network Interface is what ENI stands for. And the task that runs inside it, that's controlled by the service, it can have different networking modes. The first one's not particularly useful for what we're going to talk about today. The networking mode is called none. And typically you'd only really run this as a task for when you want to run a container that's picking up files off local disk, transforming it and writing it back. It doesn't need to talk to the internet. It doesn't need to do anything. The interesting thing to note is that the tasks and the containers within, they're pulled down through the host Elastic Network Interface. So when you start a task and you do a Docker pull, that's coming down through this interface here. The next networking mode is called host, and it's effectively port mapping. So if I started this task here and said map port 80, that will get mapped onto the host network interface. So it's a one-on-one mapping. Now, the constraints around things like this are that you can only really have one version of that task running, because the dynamic port isn't handled quite as nicely in this. So if you're trying to map port 80 to port 80, you can do that once because you've only got one port 80 on this network interface. Now, to get around things like that, we could use bridge mode, which is basically the way you run Docker on your desktop normally. You have this Docker 0 interface. Bridge mode will basically give an internal IP address to the task. The port mapping will happen there quite nicely, port 80 to port 80. And then you can use a dynamic port on the host ENI. It makes it a little bit cumbersome and tricky though to do things such as attach to load balancers, ALBs or ELBs. Luckily, ECS service handles that for you and does dynamic port pools in the background for you. And then the latest one is called AWS VPC. And this is the one we're going to actually dive in and have a look today and try and do a little bit of a demo on. So AWS VPC is the preferred way to do it. And each task that gets spun up gets its own network interface. The advantage of this is that if you're running lots of tasks on a host, you're not going to be contented on this single interface at the top. So you get a low latency, low jitter, direct access into the AWS services. And it also means that your task gets an IP address that is within your AWS VPC. Advantages of that is that you can talk to other AWS services as if you was just a normal instance running in there. And it really does make containers and tasks a first-class citizen within the AWS infrastructure. Another thing to note as well that's really, really cool about using this mode is when you use this mode, I mentioned you can have up to 10 container definitions here. These containers also share a local loopback interface. So they can actually talk to each other on 127.0.0.1 and pass traffic around that way if you don't want to do service discovery and stuff. Also, AWS VPC is the only supported networking mode in Fargate. So if you're wanting to move tasks between EC2 hosts and Fargate, this one's better to make the least amount of changes to your definition file. So in my demo, I'm going to try and explain some of the problems that you get with this AWS VPC mode. And to get there, I'm going to first of all start talking about a bit of an example task. Here I've got a primary task and I've got a helper task. And my objective is that I want to run 2 primary tasks at all times and as many helper tasks as possible. So the thing I want to do though is keep my prices down. I don't want to run lots of instances to run this. So I want to make sure I use my utilization really, really well on those EC2 instances. So let's take a C5 large. Now, on the previous screen, I was showing that I'm using half a CPU and a gig of RAM, and my helper task is just using 0.1 of the CPU and 128 meg of RAM. Now, if I go onto here and we look at a C5 large, we've got quite a lot of capacity here. I could run 2 tasks on there, and I could run up to 10 helper tasks there. Quite easily if I'm just going on pure numbers. Now the problem is that a C5 large only allows you to attach 3 elastic network interfaces. One of those is getting used to the instance. It's a primary instance interface. And then if I run 2 tasks, my 2 primary tasks that's taking half a CPU each, I've used all my network interfaces. I can't actually run any more container workload on there if it's got networking mode and it's AWS VPC. So there's my primary tasks, and I'm wasting a lot. I'm using only 1 virtual CPU and I'm using 2 gig of RAM. So I'm wasting a lot of resource there that I'm paying for, which isn't great for my budgets. So the way to get around this is something called ENI trunking. Elastic Network Interface trunking. If you're used to doing networking in the past and you've played around with Cisco interfaces and stuff like that, ENI trunking is effectively basically a trunk or a span on your Cisco network. On here, let's look at our C5 large again, same capacity, but I'm using 2 network interfaces straight off the bat with this. I've got a trunk network interface, and then I've got my primary network interface, the one that all my Docker pools are going to come through and my communication from ECS to the instance. When I SSH in, it will happen through this primary instance. The trunk ENI is basically there to set up other elastic network interfaces. And off that, you can have another 10 tasks running. So now I can attach 12 elastic network interfaces to a C5 large. And this is going to give me much more usage and better bin packing on that instance. So in this case, I've got 2 primary tasks. I've got 8 helper tasks. So I'm using 1.8 CPU and I'm using 3 gig of RAM here. So I'm getting much better. I'm very jealous of that beer burger. I'm very jealous of that. It's 9 o'clock in the morning. It would be inappropriate for me to have one. So, well, yes.
Is it?
Yeah. So, yeah, I'm using much more of my C5 large. So it's going to be cheaper for me to run this way. And if we have a look at that in numbers, a cluster with ENI trunking instances, I'm running 2 primary tasks, 8 helper tasks. I'm running 1 C5 large. The price of this has probably changed since I first wrote this. And it's roughly $140 a month. Now, if I was going to take this with some standard instances without ENI trunking enabled, I'm going to have to do something like this. I'm going to run a C5 large here because it's got enough RAM and it's got enough processor on there to run my 2 primary tasks. And then I'm going to run 5 T3 smalls. And I'm running 5 T3 smalls. I've got an extra 5 instances to run. And my rough cost is about $224 a month. The reason why I picked T3 smalls here, they're the smallest of the T3 family to support 3 ENIs. So anything below, I'd end up running even more instances for this helper task because I couldn't fit as many on one host. So it's slightly more cost efficient. Now, I'm showing this on a bit of a one-on-one scale, but if you think about scaling this across a large fleet of containers that you're running in your organization, that cost difference of, what is that, $85 really racks up quickly. $85 on one task of one service running. Now, if I'm running 100 tasks, you can see how the costs ramp up here very quickly. So ENI trunking is what we need to do. It's the best way to get better bin pack, better amount of containers on a EC2 instance running. So let's have a look at enabling ENI trunking. It's actually relatively simple here. So first of all, you make sure you've got a linked IAM role created. And what this linked IAM role does is allow AWS to basically create that trunk network interface for you. It's allowing them to reach into your account and spin up this special type of network interface. And then you can either enroll the entire account, which is what I'm going to do in my demo, or you can actually enroll a single IAM role so that when you assume that role to deploy an instance and you're of that role, that means that you can spin up instances with ENI on and you can run some without. Now, some people are probably thinking about, why don't I just run this as default all the time? Why would you ever turn it off? Well, there's certain scenarios running your container workload where you wouldn't want lots of network interfaces on a single machine. If you're very heavy CPU intensive, the bin pack is less important to you because you want to be able to just have lots of CPU and not lots of containers on the same instance. So in that case, ENI trunking becomes less useful to you, and you probably don't need it and probably don't need to run it. Once you've enabled it, you can actually see it. So you can run this ECS list attributes, and from this you can see which instances have got this enabled. I'm going to show you this with an empty set first, and then we'll get down to showing you once I've enabled it on the account. But I'm going to go through and try and show you some of the caveats and some of the ways of working with it and how you know whether it's a good idea to enable it or not. So some caveats: you have to use the Amazon ECS optimized AMI at the moment. That's the only one that's supported. I do believe BottleRocket has got this support as well now, that came recently. BottleRocket is AWS's container optimized operating system for the Googlers among us here. It's just basically a lightweight version of Linux that is designed just to run containers. And also you need AWS VPC trunking mode. one of the caveats I haven't put on here is that make sure you're actually using an up-to-date version of the ECS agent on your instances. If you're not, it doesn't work. When I originally built this demo, I fell into that trap myself by using that old AMI. Make sure you're using the latest if you're bringing up a cluster. So some limit increase examples here. So I showed you a C5 large, which took us from two containers up to 10. But when you start looking at some of the bigger instances here, a C5 18XL used to be able to run 14 containers because of the ENI limit. But with ENI trunking on, you can run a whopping 120. I mean, that's a massive increase of the density that you can pack onto that really big, really expensive instance. So this is basically run across most of the instances that run on the new Nitro hypervisor within AWS. The Nitro hypervisor is a bit that abstracts the hypervisor away from the underlying OS on the machines, the physical hardware in AWS, and it's custom built silicon that handles networking, handles connection to disk packs, all those types of things are done on this custom built silicon. So that generally is any of the latest instances. The only one that's really missing from the list at the moment is the M6s, which are the ARM processors. And I'm still waiting to hear back from AWS whether that's going to be supported soon or not, because that'd be quite a nice enhancement. If you want to jump to this documentation about how to enable ENI and how to see what the limits are going to increase to, the link at the bottom of the screen, which we'll make sure we share. I think Berger might be trying to copy that down at the moment into chat, hopefully. The link at the bottom of the screen there will take you straight to the AWS documentation, and you'll be able to get in and see what I'm talking about. Right, it's demo time. So this is where I'm going to pray to the demo gods and hope I've drunk enough coffee this morning to make this work. So the first thing I'm actually going to run here is the AWS ECS PUT account. So this is going to actually change my my defaults in my account globally for EU West 1, and it's going to enable AWS VPC trunking mode. So it's a simple command you just run. You get a little bit of JSON come back that says it's now enabled. So this is good news. This means that now when I launch instances in this this region, they will be able to take advantage of VPC trunking and ENI trunking mode. So I'm losing my voice a little bit here. So the next thing to do really here is we're going to launch a new instance. So I'm going to drop back to the console in a second. I just need to copy ARN. Let's give this one a quick update as well while we're at it and see where we are. So you can see we're now back down at the running count 1. What I'm going to do now is actually drop to EC2, and I'm going to launch a brand new instance, because it's important to know that any instance launched before I run that command, I just ran in the shell, can't take advantage of ENI trunking. Only new instances started thereafter can. So I'm going to launch a new instance. I know my AMI ID here. So this is strangely the community AMIs. I don't know why Amazon do this, but it's a bit misleading. It's actually an official Amazon ECS optimized image. I'm going to select this. I'm going to use the same type of instance to show I'm not cheating. And I'm going to go down with this massive list of instances and just choose the C5 large here. Next thing I'm going to do is going to make sure I'm in the right VPC. We're going to go into private 1 again. And then the most important bit is this little bit of bash, which I'll show you on the bigger screen. On here, this is just basically put in the user data, and all it does is echo a value into the ECS.config file that lives in /etc ECS. And it's got my cluster name in it. Add story, we're just going to go through the defaults and all this. Security group's fine. And then I'm going to hit launch. I have a key. I'm going to launch. I'm going to wait for that to start. So this is the bit where everyone's got to twiddle the thumbs and pray that there's enough instances in this region and nothing goes wrong with my demo right now. So let me just move you folks again. And we'll see we've got an instance that's coming up and initializing. So I'm going to go back to the back to ECS, and you can see we've only got one container instance at the moment, but we'll wait for that to start up. And while that's going on, I'll quickly take you to the documentation I was referring about. So on here, and let's make this a little bit bigger. So this is all the information that link that I think Berger shared with you all, because I can't see the chat window for some reason, has got. It takes you to the ASP.NET networking interface trunking options of ECS. It takes you through all the pros and cons of why to do it, why not to do it. It talks you through how to set it up, which I've already gone through with you. And then basically gives you all the service limits. And this one's a live update. So this has now got some of the new C5D instances in, which I'm not sure if I had in there at all. Like I say, I'm waiting to hear back from Amazon about when the ARM instances will be supported. So the AWS Graviton instances are pretty cool. Super low power, which means good for the environment, but they're also super fast and great for like fan out workloads. So if you've got lots of small workloads, they're a lot cheaper to run as well. So that's a good one to go for. Let's go back here. Oh, it's not started yet. This is where you hop console dashboards a couple of times, just waiting for everything to start up. As you can still see, it's initializing. So we're just going to wait for that to start, comes back on. In the meantime, I've just started a new instance off here because I forgot to add the IAM role to this instance when it was booting, so it wouldn't have been able to join the cluster anyway. You'd have thought I'd have learned after trying this demo last night and reminding myself of how to do it, but never mind. Not enough coffee yet is all I can say. So let's go to ECS as this one boots. Hey, that one's already registered itself. We've got 2 container instances running. Now, one of the things we can do if we drop back to the console and I go to the bigger window here is we've got this command here, and this is going to list instances that have got a trunk ID associated with them. So when I do this now, I get one container instance with a unique ARN assigned to it, and this will match my my instance ID and the ARN linked to that. That means that one of my instances in my cluster is capable of running enhanced ENI trunking mode, which is great news for our demo. So what I'm going to do now is I'm going to drop into the cluster again, and I'm going to go into the demo the right way. I'm going to go into this and say update, and this time I'm just going to hit an arbitrary number at 12. I don't know why I picked 12. And hopefully it'll start scaling it. So we go through and we update the service, and we drop back to this familiar view now. Desired count 12, current running is 1. And as we start looking on events, we should see some events start flooding in here as our demo scales. And you'll see that one of our container instances will only run 2, and the rest should run, and the other one should run 10 in theory. ECS can be a little bit temperamental at times when you make a change like this in the middle, but we'll see what happens and we'll see what's going. We've already got 2 running tasks, so let's see where that one landed. I've got a feeling the other one's not registered itself fully yet, and we've got this resource ENI issue coming on here. Now this might be because I jumped the gun a little bit and my EC2 instance hasn't fully passed all its initializing. Let's just check quickly. There we go, it's all good now. So what we could do is just sit and wait for ECS to realize it's now got enough resource to start placing container workloads. Oh, it started, it has realized. This sometimes takes ages to realize it can run more tasks because it's got new resources. But you see, we're already up to 5 running tasks, and we know that the first instance could only run 2. So currently, the new instance is already running 3 instances. If we wait longer and longer, that number is going to keep going up, and our number of tasks will keep increasing there. But what we're basically doing now is we've taken full advantage of the fact that I'm going to go back into the events. We've got 4 tasks have just been started here. So these tasks are now in pending state. They should start coming up. The E&Is will get assigned across to them, and everything will be happy. We won't sit and wait out the time for all 12 to start, but as you can see that we're already running more containers on that C5 large than we could before. So this is pretty good news. One of the constraints I might have put around it was I was playing around with CPU settings last night for another demo I'm writing. So we might run out of CPU on that instance before we run out of elastic network interfaces. But that's basically the concept of it. E&I trunking mode gives you far more virtual interfaces on that same size instance. You'll pay the same amount of money for it. There's no added cost. You're going to get better bang for your buck on there. So I'd highly recommend doing it. And that basically brings me to the old thank you slide.